So you may have heard that there's a problem with women in science, technology, engineering, and mathematics, also known as STEM, but what's up with that? Is there really a problem? What's the problem and what does it mean? So in this video update to the SPICE program, we're going to talk about what's up with women in STEM in brief to give you a quick overview of what the issue is and why it's important. So, despite a lot of attention from roughly the 60s and 70s to the present day, women remain underrepresented in the STEM disciplines. And there have been a lot of explanations and examinations of this over time. I'm going to give you a quick overview in 3 graphs. We're going to talk about women in STEM today, women in STEM over time, and women in STEM by career level. So first off, we have this graphic, which is a common graphic that's used to basically show how many women there are in different STEM disciplines as a percentage of the discipline. Now you see that in the biological sciences, women are actually doing quite well. They're slightly overrepresented as compared to men. But when you go into other disciplines such as chemistry, geology, and down into the engineering disciplines, you see women are quite underrepresented. These figures are very accurate. They're also a little bit deceptive. Women do make up a lot of the biological science fields, but a lot of the jobs they're in are actually at quite low levels or in health and medicine professions, which are very important professions but aren't traditionally considered part of the STEM occupations. And chemistry looks pretty high, but most of those women are concentrated in the biochemistry fields. When you get into more applied fields like mechanical engineering, civil engineering, computer programming, software development, you see a lot fewer women in these areas. And overall, women are pretty heavily underrepresented in STEM. So this is a sort of a snapshot of careers right now. Now this is a bit more optimistic graph. This is looking at women as a percentage of disciplines over time. And we see that generally speaking, women have definitely been increasing their representation in these different disciplines compared to, say, the 1960s. However, if we look at this graph in a slightly different way, we actually break it up into 2 segments, we see that most of the gain was a consistent gain between the 60s and about the mid-90s. But since the mid-90s to the present, we actually see things are kind of flat, or even in some cases women have been losing ground in disciplines like the mathematical and computer sciences. It's been pretty flat in physics. There has been a little bit of gain in biology and in engineering, but overall it's a very different trend than we saw from the decades before. And this is an issue that researchers have been grappling with for the last 15 to 20 years, trying to understand why the progress that we made in the past has started going away. And this graph gives you a little bit of a hint about what's going on with the other graph. So this is STEM disciplines by career level. So when we look at women entering undergraduate degree programs in sciences, we see that in the biological sciences, women are well overrepresented, and they're not too terrible in mathematics and in the computer sciences. However, as they move up the career and education chain into graduate school, to postdoctoral study, to tenure-track professor positions, that women continue to leak out of the system at much higher rates than men, and in all of these professions fall under between about 10 and 30% of the profession. Now, this precipitous drop in biology isn't quite as terrible as it seems because, as mentioned before, a lot of these women are getting undergraduate degrees in the biological sciences to go on and pursue careers in medicine. So some of that drop is that women always intended to be in the medical professions instead of the sciences, but still, it is a very profound drop. So at the highest parts of these careers, women are in a pretty lonely space. And this graph represents academic track, but you will see that it's very much the same if you look at private industry and other tracks for careers, where women do not persist in STEM at nearly the rates that men do. So a quick overview of what's going on with girls in STEM and where they are today. So first off, girls have closed the math and science achievement gap. When I was in high school, a lot of people were talking about the fact that girls did not perform well on tests of mathematics as boys did. Boys weren't performing so well on verbal tests either. But since that time, girls have actually closed this gap. They are earning more credits in sciences in high school and higher grades in their science classes than boys are. They've all but closed the achievement gap on international standardized tests. There is still a tiny gap, but it actually disappears in countries where you have egalitarian ideas about math and science and gender, where that gap doesn't exist at all in those nations. So it does seem to be a cultural issue rather than any sort of inherent talent of women around math and science. In fact, the fact that girls have closed this gap in 20 years, it signifies very strongly that it is a cultural issue, and girls are performing very well. One area in which girls are still behind in high school education is fewer girls attempt and complete high school physics courses, which is really important if you want to go on to a career in STEM. You really should have a foundation in high school physics before you go off to college, because most degrees do require that you take a year of college physics, and it really helps if you took some in high school. Girls are, in general, less likely to receive hands-on experiences in science. So even in classrooms in public schools that have very engaging laboratory activities where kids can actually do hands-on chemistry, physics, and biology experiments, observers find that girls tend to take more of a managerial and administrative role in these groups. While the boys manipulate the equipment, the girls are taking lab notes, writing up the lab reports, and making sure that the experiments are being carried out correctly, but they're not actually doing the hands-on work. And this is really important because hands-on work in the laboratory is the only part of these activities that is shown to foster and grow an interest in science and an excitement about science. Unsurprisingly enough, taking lab notes does not get people psyched about being scientists. While it is a very important skill, it's not fun. Evidence does show that in general, girls' attitudes towards science are improving. Middle school and high school girls see science as a positive career. They believe their parents would be proud of them if they went into a career in science, and they think it's a worthwhile career. But they're still not showing the high levels of personal interest in science that would lead to more girls pursuing science careers. Female role models have been heavily associated with increased engagement in science among girls. Some research has shown that in areas where there are a lot of women in technology and science in the community, the gap between boys and girls in taking high school physics classes disappears. Those role models, simply by being around and presenting evidence that science is a viable career option, encourages girls to pursue harder science and to stick with it more. Stereotypes about gender and science are very much at odds. So when you ask people to draw a picture of a scientist or describe a scientist, you will get almost exactly the same image every time. It's an old white dude with big fuzzy Einstein hair, mixing chemicals in a lab somewhere. He looks a little deranged. And our ideas about scientists in general are kind of conflicting. A lot of people do view scientists positively in the contributions that they make to society and the interest in their work, but at the same time, they're also pictured as being heavily male, heavily white, socially awkward, sometimes having questionable hygiene, and generally speaking, not being a person you really want to hang out with a lot. Whereas our stereotypes about young women is that girls are collaborative, they're socially oriented, they're very concerned about how they interact with other people and their appearance, whereas science is really focused on this competitive element and not really being concerned about social issues. Girls express a strong preference for careers and study that have an impact for other people or for the environment or for animals, and scientists are viewed as being very isolated. So these two stereotypes are very much at odds about what makes a good girl and what makes a good scientist. It's not very attractive to young women. It's not that attractive to a lot of young men as well, but again, we see that the bleed out is much higher among women than it is among men. There is a very masculine climate in the world of science still to this day that persists. This notion of competitiveness, ways that women are excluded from mentoring networks, having access to role models and peers who are like them, and particularly in simply the assumption of confidence. Women who pursue science education and careers find themselves constantly in the position of having to prove their scientific prowess, whereas their male peers are assumed to be competent right away. And this is a big issue. And lastly, taking all of this together overall, what we're seeing is that girls really aren't getting the kinds of opportunities, messages, and experiences that help them build identities and efficacy in science. And identity and efficacy are hugely predictive of persistence, motivation, and then ultimately success. If you don't see a career as a viable option for you, you're much less likely to consider it. If you don't consider it, you're not going to try it out, you're not going to build identities and efficacy, and you're not going to try at it. The hugest predictor of succeeding at something is simply trying. And girls are being sent a lot of messages that indicates that trying at science isn't really worth their time. So that's a quick overview of what's up with girls and women in science and why more girls aren't choosing science careers. We at the SPICE program believe really strongly in providing girls with strong hands-on experiences where they get a chance to manipulate equipment, where they are provided with role models who defy the stereotype of the crazy mad scientist and the bunker, where they can build their efficacy and confidence in science and see that the reality of science is very much a collaborative climate. Real scientists work together with one another. They do not work in isolation, and they're working on interesting, intriguing problems that do have impacts for human beings. Thank you so much. This is the second in 7 videos. I will be updating every day for the Spice Indiegogo campaign. Please share with anyone you think might be interested. And any donation you can give is a huge help. $5, $10, $25 will help a girl come and enjoy science, build an identity as a scientist, and hopefully move forward as someone who has positive associations with science and gets excited about opportunities to learn. Thank you.